Okay, so we're going to do a modeling question. We're going to create a regression. Okay, Owen is an Uber driver and his app calculates the surge rate based on the number of requests for rides per minute. This is shown in the table below. So when there's one request per minute, the surge rate, which is the multiplier for the fare, is 0.8. When there's 2 requests per minute, the surge rate is 1. When there's 4 requests per minute, it jumps up to 2.2 times what the standard fare is. And when there's 7 requests per minute, it's 6.4. The questions are: develop an appropriate model for the data, keyword being appropriate, and use the model to estimate the surge rate when there are 3 requests per minute and the requests per minute when the surge rate is 5. Okay, so what we need to do is get this data into this guy. Okay, now we know that to get the table of data into there, we have to go into stat mode. So press menu, go across to stat. Now I've got my list 1 and list 2. I'm going to put requests per minute in list 1 and the surge rate in list 2. Okay, so let's do that. 1, 2, 4, 7. 0.81, 2.2, 6.4. Okay, so now my data is into list 1 and list 2. Now, I know that this calculates list 1 as being the x variable and list 2 as being the y variable when I plot it as a scatter plot. Okay, so to work out a model, we need to hit calc and then hit regression. And there's 3 options that we're focusing on. There's linear, which is in the form of ax plus b. You might know it as mx plus c. Okay. There's quadratic, which is in the form x squared. And there's exponential, which is in the form of a times b to the x. Okay, so we have to pick an appropriate model for the data. Now what the appropriate model is if you remember back to last year and we looked at r values. Okay, so r equals, we're also going to look at r squared values here. R value just works out how many points are closest to the line. This one works out what percentage of points are closest to the line. So let's have a look. We're going to ask the calculator to make a linear model for us. Now that's in this first section, x, hit x, and there's 2 different forms for linear. We're going to use the one we know, ax plus b. Okay, and it gives you the stats on what a linear model would look like, and it gives us the option to copy that into graph mode. We won't do that just yet, we'll just look at the r and r squared. Okay, so for a linear one, r is 0.9662 and r squared is 0.9337. So what I'm going to do is I'm just going to write that down. R is 0.9662 and I'm just going to move that guy. R squared 0.9337. Okay. Hang on, 6628. Well, that'd be 663. Okay. Now, then I'm going to press exit, and exit again to get back to this row, and I'm going to look at the quadratic one. Okay, so I hit quadratic, the x to the power of 2, x squared, and you'll notice it doesn't have an r, it's just got an r squared. That's okay. We'll just put down what r squared is. The pen will work. R squared 0.9, this one's pretty good, 9999. Okay, and then we're going to go to exponential. Now exponential's on the next row of them, so I'm going to hit the arrow across exp, and now we're going to go with the ab to the x, not the e1. Okay, so, and it has r is 0.998 r squared is 0.9966. Okay, now we decide which one is the most appropriate. Now the most appropriate, a perfect model would be where these are equal to 1. Okay, so we're looking for the one that is closest to 1. So let's have a look. We've got this one, it's not too great. This one and this one is closer, 9999. That one looks pretty spot on. Okay, so now we know that the quadratic function is going to be the best model for our data. So I go back and I go back to where quadratic was, this one. Okay, I say, okay, quadratic's the best. It has an R squared value of 0.9999, and I have to write down what the function is. Now you can do it from here, okay, that's what it looks like, and that's what the A, the B values are, okay, or you can go copy, and it asks you, hey, let's put it into one of the graph mode sections. So I'm going to just hit enter to put it in the first slot. Now if I press menu, I'll just bring this more into the middle. If I press menu and go to graph and then go in, you'll see that it's in there. Whoa, that's a lot of 5s and 4s. Okay. Okay. We might round that a little bit when we write it down. Okay, so we've got y equals, this is for the quadratic one, y equals 0.1545, let's go to 4 decimal places, x squared plus negative, well that's just going to be take 0.306. Does that keep on going? Yeah, we'll go there. Oh, I may as well do this. 0.6. Okay. X plus, and then a C value at the end. 0.966 recurring. Okay. And that is our function. And the reasoning for that, justification, is that it has that R value. Okay, so when it says to ask it, develop an appropriate model, you have to give me what the model is, plus some reasoning for it. That is what the R value is, or R squared value is. Okay, so now we've got a model. Let's have a look at what it looks like. Okay, so I'm in this view, I've got my model. We have to turn on. Okay, see how the equal sign is just an equal sign. If I press the select button, can you see the difference? On, off, on, off. I want to turn it on, then hit draw. And you'll see that it looks like this. Now if it doesn't look like what you expect it to, hit shift and then go zoom, and then you can try the auto zoom, and that will try fitting the data to there. Okay. Now sometimes when you try and do the next step, it'll throw up an error. It's probably just because you zoomed in too much. If you're zoomed in too much, just hit shift, zoom, and then out, and then just press enter and it will zoom out. Okay. So let's use this model to estimate this. The surge rate when there are 3 requests per minute. Okay. So I'm going to go shift, and I'm going to go to this one called G-solve. Hit that, and it gives us a whole heap of options. Okay, the options we want is on the next screen. So arrow across, we want ycal and xcal. Okay, which one? Well, remember how I wrote x and y here? Let's have a look. What is the surge rate y when there are 3 requests per minute? So we know what the x is. We want to work out what the y is. So we're going to go ycal. Our x was 3 requests per minute. So that means the surge rate is an estimate, because it's just based off the model, is 1.439. Okay. Does that make sense? Well, 1 is 0.8, 2 is 1, 4 is 2.2, so our answer should be somewhere between 2.2 and 1. That looks pretty good. The next one, the request per minute when the surge rate is 5. Okay, so again, we had this one was we knew what X was and we wanted to find what Y was. In this case, we know what the surge rate is, we know Y, we want to find out X. So I'm going to go Shift G solve, go across, and we're going to go, we want to find out what X is, so we're going to get Xcalc. It asks you for what Y is. Y in this case, 5. X is going to be, now here we go. This is a limitation of our model. Quadratic ones look like this. Okay, linear like that, exponential has a starting point and goes up like that. Now, when we do a calculation on Xcalc, there's actually going to be two situations where Y is 5, because you've got the curve going up this way and the curve going up this way. Now it's saying the answer is negative 4.2 requests per minute. Does that make sense? No. So you just have to use your arrow across, and it's going to move over to what the other value is on this side where Y is 5. So if I press the arrow across, it's going to go over to this part of the curve, and this seems more reasonable. Okay, request per minute, 6.1938, we'll make that 4 requests per minute. Okay, does that one seem reasonable? Well, it sort of does, because this 6.194 is less than 7, okay, which makes sense. It's not going to be maybe quite where you expect it to be, because we are just doing a model that fits most of the data. We're not doing something that's going to exactly fit all of the data. Okay, that is how you do a regression model.